Let's talk about functions of several variables. Previously, we had discussed f of x and that being a function of one variable, and this is the generalization of it. So let's start with this definition. A function of two variables, f, is a rule which assigns to each pair x, y in a set D, which is a subset of R2, a unique real number, defined f of x, y. D is called the domain of f. Similarly, the range of f is the set of values it takes on, i.e. all the f of x, y's when x, y is in D. Now similarly, when we talked about functions, we had f of x. X was the independent variable and y was the dependent variable. Well, if we have z is equal to f of x, y, x and y are independent, where we can choose whatever they want, but they determine z, so z is the dependent variable. So let's talk about a specific function. If f of x, y is equal to natural log of 9 minus x squared minus 9y squared, what would be the domain of this function? Well, we know that natural log, in order for this to be well defined, that the inside has to be greater than 0. So therefore, 9 minus x squared minus 9y squared has to be greater than 0. So if we solve for this a little bit, we would say that 9 is greater than x squared plus 9y squared, which I'm going to write for now as 1 is greater than x over 3 quantity squared plus y squared. So what does this look like? If we graph this in R2 and set this equal to 1 instead, we would have the ellipse given here. Now, since this x and y have to be less than 1, what that really means is the entire domain is going to be everything inside the ellipse. Now, the boundary isn't concluded because we need it to be strictly less than 1. Because if we picked, for example, x to be 3 and y to be 0, then this inequality wouldn't be true because 0 isn't greater than 0. So the domain of this function would be this domain right here, everything inside this ellipse in R2.